All of them that I've got here are from the homework. And the first one appears to be number 2. Baloo stock is quite cyclical. In a boom economy, the stock is expected to return 34% in comparison to 13% in a normal economy and negative 22% in recession. The probability of a recession is 15%, while the chance of a boom is 4%. What is the standard deviation of returns of this stock? Okay, so I'm going to make a chart, and I would advise you to do the same thing. And what I'm going to have is the state, the probability, and the return. Okay, so let's see, they're giving us boom, normal, and recession. The probability of a boom is 4%, 0.04. And they tell us that the probability of a recession is 15%, 0.15. They don't give us the probability of normal. How do we get it?
Add 0.04, add 0.15, and then -1.
Very good. So 0.15 plus 0.04 is 0.19. And so if I take 1 minus that, I get 0.81. And the reason she knew that to do that is that all these things have to sum to 1. Now they tell us the returns in each of these situations. For the boom, it's expected to be 34%. So we're going to say 0.34. For normal times, it's supposed to be 13%. And then in recessionary times, negative 22%. So negative 0.22. Now, can anyone tell me what our next step should be? Mr. Green, what should we do next? Mr. Umfleet, what should we do next?
We multiply the probabilities by the returns, right? And then add it up.
So to get the expected return, it's just going to be the sums from I is equal to 1 to 3 in this case of the probability of the state times the return in the state. And so we've got 0.04 times 0.34 plus 0.81 times 0.13 plus 0.15 times negative 0.22. So here's what I'm going to do. I'm going to go through here and I'm going to figure each one of these and I'm going to store them 1, 2, 3, and then I'm just going to add them all together to get what I want. Okay, so 0.04 times 0.34 equal store 1. If you're getting different numbers than me, let me know. 0.81 times 0.13 equal store 2. 0.15 times 0.22 negative equal store 3. Now, how am I going to get the sum of all those?
Recall 1 plus recall 2.
Yeah, recall 1 plus recall 2 plus recall 3. I'm getting 0.0859. Is that what you're getting?
Mm-hmm.
Very good. By the way, this is the laser pointer I use to taunt my dogs. Okay, so 0.859. Now, Mr. Jaquez, can you tell me what you think the next step is going to be?
Do we square it?
Oh, you're getting close. What do we have to do before we can square anything?
Subtract.
Yeah. So we're going to have to take the return minus the expected return to get this deviation. And that's what we're going to square. And so after that, then we'll have our deviation squared. And then what's the very last column that we're going to calculate?
Product multiplied by the probability.
Yeah, the probability multiplied by the deviation squared. Now, I could go through and do each one of these columns, and that's probably what most students would want to do. But we're going to, we have an easier way. We're going to say 0.34 minus 0.0859, which is that expected return we just found. And I get 0.2541. If I make a mistake here, shout out before I get too far along. So I'm getting 0.2541 for that. Now, what button am I going to hit next?
Square.
Yep, I'm going to hit square. And that's giving me 0.0645. And by the way, 0.0646. Don't write this stuff down. The only reason I'm writing it down is so you guys can see it later. Okay, now the last step is to multiply by the probability times 0.04 equals. And I'm getting this 0.0025826 da 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 da. What should I do with that number?
Store it.
Yep, I'm going to go ahead and store it in 1. We've already finished using what we had in 1. So store 1. There we go. Now the next one is 0.13. What do I subtract from that? Ms. Bergner, what do I subtract?
0.0859.
Very good, thank you. That gives me 0.0441, which is what goes here. What do I need to do to that number next? Ms. Neuenschwander, what do I do with that next?
You're gonna square it.
Very good. And then what do I multiply by, Ms. Neuenschwander?
The probability.
Yeah, and the probability is 0.81 equal. And what should I do with this number?
You're gonna store it too.
Yep, store 2. Very good. Thank you. The next one is 0.22 negative minus. Mr. Bowrichter, what do I do next?
You add the 0.0859
We add it or subtract it?
or subtract it. I mean, yeah.
Okay, and now that I've got that number, what should I do?
Square it.
Square it, and then what do I do?
Multiply by the probability, which is 0.15.
Yep, and that's going to be store 3. So I've got this stored in location 2. I've got this stored in location 3. Now, I have all that stored. Sure, yeah. How am I going to figure out the variance of this thing?
Add store 1. Oh, sorry. Recall 1, recall 2, recall 3.
1 plus recall 2 plus recall 3 equals. I'm getting 0.018194 d. And then how am I going to get from there to standard deviation?
Take the square root.
Yep. Take the square root and it gives me 0.134888, which is 13.49%. And when we go back to our problem, we can see that that is the correct answer. Does that work for everybody? Anybody have questions about that? So the secret about this, did I really have to write anything down? I might have written the expected value down, but typically what I do is I put it store 0 and then I subtract it every time. So really you should be able to do this problem without ever writing anything down, except for I would go ahead and draw out this table to get your probabilities and returns set correctly. Are there any questions? Okay, now the next one we've been asked about is question 3. You have a 2-stock portfolio with an expected return of 11.7%. Stock A has an expected return of 13.8%, while stock B is expected to have a return of 9.2%. What's the portfolio weight of stock A? Okay, so we know, let me stop sharing here. We know that the return on a portfolio is equal to the return on A times the rate of A plus the weight times the rate for both. Now, I also know something else about this. What do both these weights have to equal to if I add them together?
1.
1. So here's what I'm going to do. I know that XA equal X or plus XB is equal to 1. And so I can say XA is equal to 1 minus XB. Or I could say that XB is equal to 1 minus XA. I'm going to do this second one, and you'll see why here in a second. And I'll go ahead and tell you the reason is that we're being asked for XA, so I'm going to keep everything in terms of XA. If you did it opposite, it would be easy enough to do the subtraction at the end. And so I'm going to say now the return on the portfolio is equal to XA RA plus 1 minus XA times the return on B. And so now I can start filling in some numbers since I know some numbers. The return on the portfolio, they tell me, is 11.7%. And in this case, we can use percentages, but you could use decimals if you're more comfortable. We don't know X sub A, but we do know the return on A, which is 13.8%. And then we have 1 minus X sub A times the return on B, which is 9.2%. Now I'm going to use my distributive property. 11.7% is equal to, and I'm going to scratch out these percentages because after all, those are going to cancel, and I'm tired of talking about them. So I've got 13.8 XA plus 9.2 minus 9.2 XA. All I did was use the distributive property here. 1 times 9.2 gives me 9.2 minus XA times 9.2 gives me minus 9.2 XA. Now, what should we do next? Mr. Holman, what should we do next?
Put the X sub A variables together and also get the 9.2 over with 11.7.
Yeah, so we're going to do two things. We're going to subtract 9.2 from both sides. So if I've got 11.7 minus 9.2, that's going to give me what, 2.5 over here. And then on this side, I've got 13.8 minus 9.2 equals 4.6 X sub A. Does that look good? Does that look okay to everybody? Okay, what's the last step? Mr. Green, are you back with us? I guess people didn't think that I would actually call people out today, huh? Ms. Ware, what should I do next?
Divide by 4.6 on both sides to get 0.5435.
Yeah, 0.5435, which is 54.35%. And if we go back to the screen, boom. Come on. There it is, 54.35%. Any questions about that one? So the whole trick there was just remembering that the weights always add to 1. Okay, now we're on to number 7. What's the return on a portfolio which is invested 20% in stock A, 50% in stock B, and 30% in stock C? Okay, now this looks like it's going to totally freak you out. And I guarantee you that this is something you should save till the end, but it's not nearly as nasty as it might first seem. Here's what we're going to do. We're going to figure out the return for the portfolio in each state of the economy. And then we're just going to treat that portfolio as if it is a single stock to get our expected return on that. And actually, the way I'm going to set this up would make it very easy then to solve for variance. In fact, that's what I thought we were looking for here, but it's actually quite an easy one. Maybe the next one's the variance. Okay, so here we go. I know that the expected return on a portfolio is just the weights times their expected returns. Okay, so the weight on stock A is 20%. And this return for stock A in the first boom scenario is 0.18 plus the weight on B is 50% times the expected return on B in the boom is 9% or 0.09 plus, by the way, did they even have to tell you 30% on stock C? We know those weights have to add to 1, so I didn't even have to tell you that. 0.06. Now this is for boom. And so the expected return for boom, we're going to calculate that out. But here's the way I'm going to do it. Just to make the math easy for me so I don't mess things up. 0.2 times 0.18 equal store 1. 0.5 times 0.09 equal store 2. 0.3 times 0.06 equal store 3. So then I'm going to say recall 1 plus recall 2 plus recall 3 equals. I'm getting 0.099. Is anyone getting something different? Speak up if you're getting anything different, please. Okay. Now, the next state of the economy was normal, and the weights are all the same, but the returns are different. And so this time we've got 0.11, 0.07, and 0.09. And so once again, I'm going to go through here. I'm going to say 0.2 times 0.11 equal store 1. 0.5 times 0.07 equal store 2. 0.3 times 0.09 equal store 3. Recall 1 plus recall 2 plus recall 3 equals. I'm getting 0.084. Is anybody getting a different number than that? Okay, and then finally, we need to talk about recession. Once again, the portfolio weights are the same. In recession, this one has got minus 0.10. This one has 0.04. This one has 0.13. So here's what I'm going to do. I'm going to say 0.2 times 0.1 negative equal store 1. 0.5 times 0.04 equal store 2. 0.3 times 0.13 equal store 3. Recall 1 plus recall 2 plus recall 3 equals. I'm getting 0.039. Ms. Baldwin, is that what you get?
Yeah,
Very good. Okay, now we went through all of that. How then would I find the expected return for the portfolio? For overall, this is per state. I'm going to go expected return of the portfolio is equal to the probability of the boom 0.20 times the expected return in a boom 0.099 plus what's the probability of a recession or of normal is 70%. And then a return in normal times is 0.084 plus the probability of this last one is 0.10 times return in that state is 0.039. So now I can go through, say 0.2 times 0.099 equal store 1. 0.7 times 0.084 equal store 2. Make sure I got that one right. 7 times 0.084. Okay. And then 0.1 times 0.039 equals store 3. How do I get the expected return on the portfolio with those numbers?
Recall
Adding
one.
Yeah, recall 1 plus recall 2 plus recall 3. I'm getting 0.0825, which is 8.25%. And if we go back to problem, that is the correct answer. Questions?
We will get the same number if we would do instead of the expected return of each state of the economy on the expected return on each stock, correct?
Yeah, and so in fact, what you could have done is found the expected return on each stock. So let's talk about stock A. It would have been 0.2 times 0.18 plus 0.7 times 0.11 plus 0.1 times minus 0.1. And we would add all that together. That would be the expected return on stock A. And we do the same thing for stock B and stock C. And then we just go through and apply these weights, 20% times that expected return on stock A, 50% times the expected return on stock B, and 30% times the expected return on stock C. The reason that I went ahead and did it the way that I did was because when we start looking at if we were going to calculate variance or standard deviation, it's a whole lot easier if we do the portfolio and make it look like a single stock. But you're absolutely right.
Yeah, like question 8. Like I
Oh.
asked you through email, but I still cannot figure it out. Like I don't get the number.
Oh,
I
okay.
don't know. Yeah.
Well, heck, we're going to work that right now. Okay, so this one is going to be nasty. So I'm going to start with a clean sheet of paper. They ask us, what's the variance of portfolio consisting of 3,500 in stock G and 6,500 in stock H? By the way, what's the total value of the portfolio?
10,000.
Yeah, 10,000. So what would the weight on stock G be?
0.35.
It would
Very
be
good.
0.35.
Yep. And then what would the weight on stock H be?
0.65.
Yeah, 0.65. And then you can check your work by adding those together, make sure they equal 1. Okay, they tell us that we have 2 states of the economy. So this is going to make life a whole lot easier. Boom and normal, 15% chance of boom, 85% chance of normal. And then they give us the returns if the state occurs. And so we're going to take that information and we are going to first figure out the expected return for the portfolio in each of those scenarios. And then we are going to figure out the variance from there. So I'm going to take a little drink of water here and we'll get going. So we have the state, boom, and norm. We have the probability, 0.15 0.85. Probabilities always have to add to 1. Now, we have the returns on these stocks. And so what we need to do is figure out what is the expected return on the portfolio in the boom. And we need to figure out what is the expected return on the portfolio in normal times. So the way I'm going to go about this is by figuring out. So we're going to have 0.35 times the return on stock G, which is 15% in boom time, so 0.15, plus 0.65, that's the weight on H, times the return on H, assuming a boom occurs, which is 0.09. So I'm going to go ahead and do that math. 0.35 times 0.15 equals 0.0525. I'm going to store 1. 0.65 times 0.09 equal store 2. And then to get the expected value, I'm going to say recall 1 plus recall 2 equal. I'm getting 0.111. Is anybody else getting that number? Or anybody not getting that number? Okay, I'm going to assume it's correct then. 0.35. This time we're looking at the return on stock G in normal times, 0.08 plus 0.65, the weight on H, times the return on H in normal times, which is 6% or 0.06. And we're going to do the same process here. 0.35 times 0.08 equal store 1. 0.65 times 0.06 equal store 2. Recall 1 plus recall 2 equal. I'm getting 0.067. Is that what you guys are getting?
Yes.
Yeah.
Very good. Okay. So now how am I going to find the expected return on the portfolio overall? Anyone have any idea how to start?
By multiplying with the probability of the state.
Yeah, by going with the probability of the state. And so we've got 0.15 times 0.111 plus 0.85 times 0.067. So I'm going to say 0.015 times 0.111 equal store 1. 0.85 times 0.067 equal store 2. Recall 1 plus recall 2 equals. I'm getting 0.058615. Does that sound right? That does not sound right, does it? Let me try that again.
I got 0.0736.
Yeah, I think that's right. Okay. So just to make sure we got this, 0.15 times 0.111 equal store 1. 0.85 times 0.067 equal store 2. Recall 1 plus recall 2 equals. Yeah, there we go. Okay, now here's what I'm going to do. I'm going to say store 0 because that's the expected return that I'm going to subtract to get my deviations. And the deviation is going to go right here. And then after I figure out the deviation, what do you think I'm going to do with that?
Square it.
Yeah, we're going to square it. And then what's the final column over here?
Multiply the probability.
Yeah, probability times the deviance squared. Okay, so let's go ahead and do this. And I'm not going to write these down, but we're going to go all the way across. I'm going to take 0.111 minus recall 0. I'm getting 0.0374. I'm going to square that. I'm getting 0.00139 and some stuff. Now, the very last step, I'm going to multiply by the probability. I'm getting 0.0002. Is that what you guys are getting?
Yes.
Okay. I'm going to say store 1. I'm going to write my little 1 in a circle there. Now the next one, I'm going to say 0.067 minus recall 0 equals, then I'm going to square it and multiply by the probability, 0.85 equal. I'm getting 0.0000370026. Is that what you guys are getting? Did I mess that up? No, I think I got that right. So we're going to say,
That's what I got.
okay, store 2. Now, how am I going to get the variance for this thing?
Recall 1 plus recall 2.
Yeah, recall 1 plus recall 2 equals, and I'm getting 0.0002464. And if we look at their answer, they're getting 0.000247, which is the same thing that we got. I'm telling you, it's a whole lot easier to get the expected return of the portfolio and then figure out the deviation, the returns on the, or figure out the returns on the portfolio and then figuring out the variance based on that, rather than trying to figure out the covariance between these things and using that 2xAxB covariance A with B, blah, blah, blah formula. Whole lot easier. Questions?
Yeah, so the first time I did this, I thought that I could do take the 3,500, 6,500 part at the end, but do you need to, like, it's really important to multiply those weights at the very beginning. There's no way to do it at the end.
Okay, so those are just the weights inside the portfolio. So if you go ahead and do, I don't even know how you go about it, but if you did stuff and then at the end tried to do something with that, you'd be in a world of hurt.
Right, that's where I was. I'm so confused.
Yeah. Yeah, this is
all right. Thanks for going over that one.
Oh, you're welcome. And if you want to watch this one more time, I have a video. It's an example video, and it says 2-asset portfolio. The first 2 minutes and 53 seconds is about going over the regular way. And then the last bit is how to do this thing. And so this thing, even though it takes longer to explain, it's actually easier to do. So I would recommend this technique instead of trying to find covariance or correlation. Okay, so we've got 1 in chapter. Oh, any other questions from this chapter before we move on?